Hello friends, welcome to CS Tutorials. Today we'll be talking about a data structure arrays. And what are we going to be talking about in this video? We're going to be talking about a definition, how to declare an array, initialization of an array, and the memory allocation, and most importantly, the time complexity of an array. Without wasting too much time, we're going to jump into this. An array is a collection of data of the same type stored in a sequential order. I'll say that again. An array is a collection of data of the same type stored in a sequential order. And if you don't understand that, in the next slide might give you some visual understanding of that. And at initialization of an array, we must have a predefined size. So if we don't know the amount of space we need for this data we're trying to manipulate or handle, we cannot use an array. We have to look to a different data structure. And while iterating through our array, we use an index. And in the next slide, you will have a better understanding of this. How do I declare my array if I don't want to populate it immediately? I don't know for example, I don't know the values I want to put in my array off the bat. How can I handle this? But I know the amount of space I need. I use this first approach. With this first approach, I know I give my array name, my array type, which is very important. My array type for this is an integer, my array name, and I use this new int. And in the braces, I put the size of my array, and I set it to 10 because in this case, I want 10 spaces. Oh, now I know what the first value is supposed to be. The index of the first value is 0. In arrays, not to go out of order, but in arrays, if you look down here in our diagram right here, the index for this 10 sized array starts from 0 and it goes all the way to 9. So if my array size is 12, my index will start from 0 and will go all the way to, you got it, 11. So that is how it works. The indexing of the array always starts from 0, which is the approach that's taken here. So my array at 0, I just want it to be 2, and voila, it is 2. My array at index 4, I want it to be 56, and it stores 56 in that memory space. But if I already know what the inputs of my array should be, why do I need to go through from 0 all the way to 9 doing this one by one? That's a waste of space. Yes, I can just do it all in one line. And I define my array type, give it a name, and I just assign the values this way. So my new array, my array is going to have the value 2, 32, 1, all the way to 32. And if you're like me and you go through those values and you realize, hey, we already encountered 2 before. Hey, we already encountered 32 before. Arrays are very friendly with duplicates. As a matter of fact, every input in my array can be 2s. Every input in my array can be just 1 or just 0. It can be whatever value I want it to be. But as this is defined, it has to be an integer. So whatever integer value I want it to be, my array can have that value. So arrays are friendly with duplicates. And if you can see, this array is not sorted because we have 2, 32, 1, 5, 56. There are a lot of questions out there, especially in interviews, where they ask you to probably sort an array, or they ask you a question that involves you having to sort an array. And in subsequent videos, we're going to discuss about sorting arrays, and we're going to solve the problems in sorting arrays. Um, this visual description we have here kind of gives you an understanding of how the memory looks. So on the memory, there are, when I define this, for example, this is the approach I decide to take. It reserves, uh-oh, on the memory, this 10 spaces, consecutive spaces, are reserved on the memory for me. And the name of those space is my array. So when I start to index and put stuff in there, it just goes consecutively because the index already applies to the consecutive numbering from 0 of the memory space that was allocated for my array. I hope you understand that. If you don't, we can leave a comment and we can explain a little bit more. And the time complexity of arrays for inserting, we linear insertion is O of n, worst case is O of n. Linear deleting is O of n, worst case is O of n. Um, read for us to be able to read a value, which means we have the index of where that value is O of 1 because we're not searching for it. We already know where it is. The worst case is O of 1. For search, for linear search, going through each element, trying to find where our item that we're looking for is, our element we're looking for is O of n. The worst case is O of n. And there are different other search algorithms that can help us improve this, which we will discuss in our subsequent videos. But this is linear, is a linear search, and it's O of n. Why do we use, or when do we use um, arrays? Like I said previously, this just to recap, we use arrays when we have a fixed size. The disadvantage of this is if I go and I define my array for 10, and while I'm writing my program, I realize I need space for 12 elements, 12 items in my array. I have to make a new array because that memory has already been allocated, and that is I cannot just increase the size and say, oh, hey, you know what, just plus two more spaces. It doesn't work that way. So that's one downside of using an array. But besides that, that's kind of everything you need to know about arrays. In our subsequent videos, we're gonna be solving problems using arrays, learning how to use arrays with hands-on coding. So look out for those videos and happy coding.